Now, let's go to the performance parameters for internal combustion engine. So, for the specific fuel consumption, so we have your equation. So, we have here the specific fuel consumption. So, that will be the mass flow rate of your fuel divided by the brake power. Okay. So, this is clearly defined dito. So, that is the ratio yung specific fuel consumption. Then it is also equal to 1 over the we have here 1 over your enthalpy. This is a change in enthalpy, and we have the arbitrary overall efficiency. So this is also equal to yung specific fuel consumption is also equal to the 1 over the calorific value, or can be then multiplied to the overall arbitrary efficiency. Then it is also equal to 1 over your higher heating values of your fuel times the overall arbitrary overall efficiency. Now our mass flow rate of your fuel is equal to the volumetric efficiency times the Bs. So that will be that one is, then we have volumetric efficiency, then this is Vs, is the volume swept by the piston. Then your N will be your RPM, and we have your density of air divided by AFR, so the apparent air fuel ratio. So that is also can be breakdown and equal into volumetric efficiency. So volume swept, then RPM, so the value of your density, so that will be the pressure of your air divided by the R of air, then temperature of air, so that is temperature on outdoor, okay, divided by the actual air fuel ratio. Then we have the indicated mean effective pressure, IMEP. So this defined as the mean effective pressure is the average pressure exerted on the piston. So during each power stroke, and it is determined from the formula or by means of planimeter. So there are two kinds of MEP. We have indicated mean effective pressure, so which is developed in the cylinder and can be measured, and brake mean effective pressure, bmep, which is computed from brake horsepower delivered by the engine. Now, for indicated mean effective pressure, so it is defined as the measure of indicated work output per unit swept volume in a form of independent of the size, number of the cylinders in the engine speed. So we have your IMEP, which is equal to indicated work output, that will be in the units of Newton meter. Now this is for per cylinder per mechanical cycle. Then it is divided by the swept volume per cylinder. So we have your cubic meter for the units of that one. Then for our brake mean effective pressure, bmep, so take note yung IMEP, so that is mean effective pressure. So yung unit niya natin, so that is pressure. So ang unit natin is Newton. Take note, unit is always Newton per square meter. Now, for bmep, we have brake work output, that will be Newton per Newton meter, no? Per cylinder per mechanical cycle. So we have your volume swept divided by volume swept per cylinder. That is also cubic meter. Now for brake power is equal to bmep. Now for the brake power, we have to para makuha natin siya, so that is equal to bmep. So we have multiplied to LAN, which is L symbols for your piston stroke. So that is the movement of your piston from one point to another. So that defines that one. Then we have your area. So this will be your area, the surface area of your piston in the internal combustion engine, and your N. So that will be the number of mechanical cycles of operation per second for all the pistons. So take note that N with asterisk, this one, so is equal to N prime divided by N. So this is the units of revolution per second. No? Now for two stroke, okay? So this is for two stroke. Now, for 4-stroke, so it will be revolution, yung RPM mo will be divided by 2 for single for 2-stroke on for 2-stroke only, so that is automatically the RPM. Now if we have 4-stroke engine, so it will be divided by 2. So your bmep now is again is equal to bmep blan, so which is your n, so that will be defined as yung number of the cylinders, okay, then multiply by the n with the asterisk, then is equal to bmep is equal to volume swept, so engine swept, no, so this is the unit of cubic meter, then it is n asterisk, then it is equal, now your brake power is equal to 2 pi tn. So you will see the variance of the equation, so and it will always equal to the brake power. So we have the variance of equation here if yung mga other properties are not given, so you can look aside other equation para you come up with a solution. Now let's go to the mechanical efficiency, so that will we have your symbol here, and a frictional frictional mean effective pressure Fmep. So Fmep is equal to Imep minus your mean effective pressure minus your brake mean effective pressure, so that will be your frictional mean effective pressure. Now for mechanical efficiency, so we have here your brake power divided by your indicated power. So usually brake power that is already on the the power that is already on the shaft of the transmissions or shafting of the internal combustion engine. So this is already the output. Then this is the indicated, which is already in the computed, no? Now indicated efficiency, this one, so it is equal to Wi, so that will be indicated work divided by the mass flow rate of your fuel times the calorific value of the fuel. So this is also equal to the work divided by the mass flow rate of your fuel multiplied by the calorific value and the mechanical efficiency. So, and also this can be equal to arbitrary overall efficiency, no, divided by the mechanical efficiency. So we have here the variance of equation that can be used in order to get yung indicated efficiency of the internal combustion engine. Now for volumetric efficiency, we have your symbol here. So it is equal to the mass of air inhaled per cylinder per cycle, then divided by the mass of air to occupy the swept volume per cylinder at ambient pressure and temperature. So that is the amount of air that can be intake by an internal combustion engine. So that is the volumetric efficiency. Okay, assuming air obeys the gas law, so for your volumetric efficiency, we have the volume of ambient, okay, density air inhaled per cylinder per cycle divided by the cylinder swept. Okay, then our volumetric efficiency is equal to the volumetric flow rate of air with the ambient density, this one, divided by the volume swept times the stroke of your engine. Okay, next we have the amount of brake work produced per cycle, so that is equal to the pressure, then volume swept, then we have your RPM. Okay, so it can be also have a variance to the mass flow rate, then we have your efficiency, then the calorific value, then your work brake times your volumetric efficiency, volume swept, density of air, and we have the apparent air fuel ratio, then the brake efficiency and the calorific value. Now the specific air consumption, or SAC, so indicates how good a combustion system is at utilizing the air trapped within the cylinder. So the indicated specific air consumption is, or ISAC indicated, is equal to the apparent air fuel ratio times the indicated specific fuel consumption. Now to get the brake specific air consumption, so we are BSAC, so that is equal to the apparent fuel air fuel ratio times the brake specific fuel consumption. Here we have a sample problem. So a 2-liter 4-stroke indirect injection diesel engine is designed to run at 4,500 RPM with a power output of 45 kilowatt. The volumetric efficiency is found to be 80%. No? The brake-specific fuel consumption is 0.071, that will be kilogram per megajoule. And the fuel has a calorific value of 42 megajoule. The ambient condition for the test were 20 degrees Celsius and 1 bar. So calculate the brake mean effective pressure, the arbitrary overall efficiency, and the air-fuel ratio. Okay, so first things first, no, we need to establish yung what are given on the problem. So we need to identify kung ano yung mga given sa problem. So let's try to do that, yung identify what are those given. So for the given, okay, given on the problem, we have your RPM, no? So you have your N, so that will be equal to, so we have here 4,500. So that will be your RPM. Then we have your power output, which is 45 kilowatt. So that is already the brake power. So we have your brake power dito given already. So this is your work brake. So that will be equal to 45 kilowatt. Then we have next is the volumetric efficiency. Okay, so we have 80% of your volumetric efficiency. Then we have the brake specific fuel consumption, bsfc. So that is equal to 0.071, that will be kilogram per megajoule. Then we have also the fuel calorific value, that will be your CB, no? So that will be our CB, which is equal to 42 megajoule per kilogram. Then we have your ambient temperature. So we have your T1, which is 20 degrees Celsius. So I will automatically plus this one by 273.13. So to make it in absolute value, okay, so this will become 293 point 273.13. So we have the units of your Kelvin dito. Then we have also your pressure, atmospheric pressure, which is 1 bar. So this is equivalent to 1 bar is an equivalent to 10,000. Sorry, this is equal to 100,000. So 1 bar is equal to 100,000 Pascal. Then we have so the ambient conditions, so calculate arbitrary. Okay. So a 2-liter 4-stroke. So we have the BS, or the volume square, you know, since it is a 2-liter. So this is 2 liter. Okay. So that would be our given to the problem. Then we need to establish also ano yung unknown to the problem. Now, so ito yung hinahanap. So we're looking for the brake mean effective pressure. So I'm gonna write here what will be the unknown. No? So for the unknown, so write natin yan. So that we be able to yung mga equation that we need na kailangan natin sa calculation. So we have also unknown of arbitrary overall efficiency. So that we may able to establish what the equation na kakailanganin natin. Then also we need to determine the air fuel ratio. So this is pwede na itong the air fuel ratio, actual air fuel ratio. Then, I'm gonna write here yung mga required na equation na gamitin natin. So, we need to determine the brake mean effective pressure. So, from brake power, remembering yung kaninang lecture, so we have your brake power. So, that will be equal to your bmep, no, times ln or length of stroke, surface area